In this video we're going to take a look at converting an annual rate into a monthly rate. So the type of question that could come up is find correct to 4 significant figures the rate of interest per month that would, if paid and compounded monthly, would be equivalent to an effective annual rate of 3%. So all we're looking at here is if we had something being compounded monthly, what would the interest have to be for that to effectively amount to an additional 3%? And because it's compounded, we're going to use the compound interest formula here. So I've got F is equal to that. So I'm going to need to identify my F, P, I, and T. F is what we want out at the end. And if we are doing this to get an annual rate of 3%, that means that at the end I want to have out 103% of what I put in. Or I could say 1.03 of what I put in. The next thing that I need to figure out after I've got the F, so just identify your numbers, what you're going to fill in and into the formula. The next one I need to identify for myself is the P. What am I putting in? We don't really need to know what we're putting in. You can say I'm putting in a value of 1 and I know what that's going to be coming out as. Then I know that it's going to be 1.03. because it's going to be an equivalent rate of 1.03 coming back out. The I then is the interest, and that's the part that we are interested in. That's what we want to figure out here, is what does the interest have to be if it's compounded monthly, if we're to get out an equivalent of the 3% at the end. So I don't know what I is, and that's okay. I'm going to leave it be I for the moment. T then is how long it's going to be compounded for. So because we're saying we're taking a yearly rate that is 3% and we're doing it monthly instead, there are 12 months in the year. So I'm going to be subbing in 12 for T then. And I just want to substitute back in what I know then. And even the letters I don't know, just keep those the same. So I'm going to have F, which is 1.03, because I know at the end that no matter what the interest is, that I know that it should accumulate to 3%. I put in 1, and then I'm going to say 1 plus I. I don't know what the I is, so I'm just going to leave it as it is. So it's going to be 1 plus I. And from there then you can start to see that it's actually just a little bit of algebra. So if I want to get I on its own, I would have to say, okay, get rid of that 12. How do I get rid of to the power of 12? Well, I'm actually going to get the 12th root of both sides. So that small 12, be careful of the notation and how you type it into your calculator. That's the 12th root of 1.03. It's equal to 1 by 1 plus I, which we're looking for I. So what would I do to get I on its own, or even more on its own? Well, I would take away 1 from both sides. So then I'd be left with what I had before, whatever that is in my calculator. And now I'm going to have that, and I'm going to subtract 1 away from it, so that I'm getting I on its own. So take away 1, and then I'm going to have I. And if I put all of that into my calculator, what I get out is that I is going to be equal to 0.002466. Now that is I as a decimal. If I want it as a percentage, I would need to multiply it by 100. So to get it as a percentage, multiply that by 100, and I'm going to get 0.2466%. And that is what the monthly rate would need to be to amount to an annual equivalent of 3%.